Hello everyone, this is Adnan and welcome to Chemistry with Adnan. In this lesson, we will be covering topic-wise practice questions on 4.1 electrolysis. The exam board is IGCSE Cambridge, Cambridge Chemistry. The course code is 0620. So as you already know that I also offer one-on-one tutoring lessons. So if you need one-on-one tutoring session, you can fill the Google form that is given in the description. And you can also join my community, high school community on school.com. It is free to join, where I offer one-on-one and group lessons as well. So you can subscribe to the premium cap package for monthly, group lessons 4 times a month, once a week. And there's one lesson per month, which is totally free. And it is a good place to be when, if you need to ask questions or participate in discussion forums. So, okay. So this topic is considered to be a difficult topic, and many students they struggle, in understanding this concept of electrolysis. And I've made 2 separate videos on this: 4.1 electrolysis for core students, and 4.1 electrolysis part 2 for supplement students. So in this lesson, we will also be so this is a practice session where I've filtered questions from the past papers related to this topic, 4.1 electrolysis. And we will see that whatever we have studied in our previous 2 lessons, so now we will apply these lessons, whatever these concepts on these lessons. Okay, so the first question is: the chemical elements are arranged in the periodic table in groups and periods. Molten silver bromide is electrolyzed using graphite electrodes. Name the product formed at each electrode. So how will you answer this question? So you can see that the first thing is that you should see that what is being electrolyzed, right? And it is silver bromide. So it doesn't matter if you know the formula. So you know that silver is a metal, so it will have a positive charge, right? So metals, they have a positive charge. And bromine, bromide is made of bromine, so it's Br negative. So non-metals, they carry a negative charge, right? So non-metals, they carry a negative charge. So in this case, you can see, and it is molten, so there is no involvement of water. So you have a container in which you have a molten solution. You have molten silver bromide, and electrodes are dipped into this molten silver bromide. So we have silver on one side and bromine on the other. So in these electrodes, let's label this one a positive and this one negative. So this is our cathode. So remember, what you need to remember is that cathode can contains a negative charge, and anode, it contains a positive charge. So silver, containing a positive charge, will be attracted to cathode, right? So product at the cathode, it will be silver. And product at the anode, since anode has a positive charge, so the non-metal, which is bromine, it will go to the positive electrode, which is anode, right? So here they are testing your understanding that whether do you remember that what is the charge on each of these electrodes? What's the charge on the anode? It is positive. And what's the charge on cathode? It's negative. This is the thing that they are trying to assess. And the other thing that they are trying to assess is that you have this understanding that the opposite charges attract, right? So silver, carrying a positive charge, it will be attracted towards cathode, and bromine carrying a negative charge will be attracted towards the anode. So this is how you answer this question. The next question is, so part D, figure 3.2 shows the apparatus used to electroplate a metal object with silver. All right, state why objects are electroplated. Okay, easy question. Don't get scared by this diagram. And so what they are asking is relatively simple. So to improve their appearance, right? So we have studied this in our topic, electrolysis part 1. that why do we electroplate things, so that they can look good, and to minimize their corrosion, right? Or so that we can make them resistant to corrosion. So we can use easier version of this answer to improve their appearance. Okay, you can also say to improve resistance to corrosion, but you may have you may write the spellings incorrectly, like resistance and corrosion. So I think this is an easier answer. But let me write the other one as well. To improve resistance, resistance, resistance to corrosion, corrosion. All right. Next question. Potassium iodide is an ionic compound, and molten potassium iodide is electrolyzed using graphite electrodes. Name the products formed at the positive and negative electrode. Okay, so this one is easy because it is not asking you that what will be the product at anode and cathode. So this question number one, or 1C, this was a bit difficult than this one, because it is not telling you which one is negative or positive, right? So you have to figure that out by yourself. But this one, it is an easier version of the same question or the same concept. So now we have already you can pause this video here and you can figure it out yourself, that potassium is from group 1, so it's a metal. Iodine or iodine is from group 7, so it's a non-metal, so potassium will have a positive charge, and iodine will have a negative charge, right? So positive electrode, it will be iodine, and a negative electrode, it will be potassium. That's it. Okay, and it is molten, so there is no involvement of water here. So no comparing the reactivity series, or no oxygen and things like that, right? So state the name of the positive electrode in an electrolysis experiment. Oh, you see, so they are asking this. So positive is anode. Okay. So now we move on to the next one. And this question is about sulfur and compounds of sulfur. So blah, blah, blah. Name the product, name and the products, and state the observations at the positive and negative electrodes. So the product at the positive electrode. Okay, so the word dilute here, it shows that it involvement of water, and a sulfuric acid is being electrolyzed. So sulfuric acid, it gives us, so this is much more difficult question than the previous two, question number 1 and 2, since it involves aqueous electrolysis because of the word dilute, and sulfuric acid is there. So sulfuric acid dissociates into H plus, and HSO4 minus, or 2H plus, or and SO4 sulfate ion, right? So now, okay, so but we will also have hydrogen plus from water, and OH negative from water, right? So we have two positive ions, and we have two negative ions. Okay, so now name the products and state the observation. Okay, so you see, we have to name the product as well, and we have to, state the observation. So the product at, the product at positive electrode. Okay, positive electrode is anode, right? So yeah, so since there's no involvement of halide, so in that case, oxygen will be the product, right? So okay, I think I skipped this one. So let's come back to this when I solve this here. So the product, so this one is positive is anode. Okay, label figure 4.2 to show the cathode. Cathode is this one, the negative one. So this one is cathode, right? So you just write it like this. And the electrolyte that we are using is, so that's the electrolyte, and this is the solution, right, in the beaker, in the container. So that's the electrolyte. Okay. So now this question, yeah. So since we don't have any halide here, so it's either oxygen or a halide at the positive electrode or at the anode. So here the answer will be oxygen. We have studied this in detail in our previous video. So if you haven't watched that, so go watch that video. I'm linking it above here, and in the comments, I'm in the description as well. So you go watch that and then come back and you will be able to answer these questions by yourself. So and what will be the observation at the electrode? So since there's no metal to compare in the reactivity series with hydrogen, so the answer will be oh, this is observation. Yeah. So since it's a gas being produced, so bubbles. And a product at the negative electrode, it will be hydrogen, because there is no metal involved, and so hydrogen will go to the anode, sorry, the cathode. And observations at the negative electrode, again, hydrogen is a gas, so it will be, the observation will be bubbles. All right, so let me quickly give you a little perspective here. I don't want to go to another video to understand this. So in aqueous electrolysis, when water is involved, so in order to understand that what will be deposited at anode, so it's the less it's either halide or oxygen. Nothing else can be deposited, right? So what is the rule for halide? So halide must be present in the in the electrolyte, right? So here we don't have that, so halide is ruled out. So it is oxygen. So if the solution contains halide, so then it will be a halide instead of oxygen. So that's the rule for the what will be deposited on the anode. For cathode, that is negatively charged. So you compare the ions, positive ions involved in with the reactivity series. So whichever element is the least reactive, so that will be deposited, right? So for example, it's potassium or so it's potassium. So if you compare, so hydrogen in the reactivity series is less reactive than potassium, so hydrogen will be deposited and the potassium will remain in the solution. But if you have any something else, like for example sulfate, that is not included on the reactivity series, then again hydrogen will be deposited and this will remain in the solution. It will not be deposited, right? So what are the limitations? Like only two things can be deposited at cathode: hydrogen or or a metal, right? Or a metal that is less reactive, and that is less reactive, than hydrogen. Okay, so I hope this is clear. Now we move on to the next part. Lithium bromide, okay, lithium is a metal. It will have a positive charge. Bromine will have a negative charge. State the names of the products at each electrode and give the observations. So positive product at the negative electrode, so it will be lithium. And product at the positive electrode, it will be bromine. Because it has a negative charge, it will be attracted to the positive electrode, and the positive electrode is called the anode. And negative electrode is cathode. Okay, so observations at the positive, yeah. So a bromine is a brown, liquid with vapors, right? It has a low boiling point and high vapor pressure. So bubbles. So it will be red brown vapor, red brown. VAPOUR. Okay. So now next question number 5. Table 5.1 shows the properties of four substances, blah, blah, blah. Uh, Potassium bromide can be electrolyzed. I think, do I have to fill this table? Because I can see that there are some, no, I think let's skip this one. Sulfur, I think it doesn't, this question might not be related to the L2 electrolysis, but let's skip this. Okay, let's come here. Molten potassium bromide. Potassium bromide, again, potassium is positive since it's a metal. Bromine, it's a non-metal, so it will have a negative charge. At anode, we have answered this question before. So, the anode is positive and cathode is negative. So now it is easier to answer. So at anode, you will have bromine. And it is asking about the product, not the observation. So so you must cross-check whether the question is asking about the a product or the observation. So some like students who are in a hurry and do not attempt their paper carefully, they may sometime write the opposite, right? So like the question might be asking about the product, and they may write the observation, so they will get 0. At cathode, it will be potassium. So you can also write their symbols since periodic table is given, but writing a name is always a safer option because bromine, it exists in the form of Br2. So if you write Br, so you may not get any mark, right? So just to be on the safe side, just write the answer in English. Okay, like as a word, not as a symbol. Question number 6, lithium is extracted by the electrolysis of molten lithium chloride. Name a non-metal used to make the electrodes. Okay. So yeah, so a non-metal use of graphite, right? So graphite. Okay. So graphite is used. It is a form of carbon, an allotrope of carbon that can conduct electricity. All right, that is why it is used as, and it is also inert, right? So electrodes must, any electrode must have two properties. It should be inert, and it should be able to conduct electricity. Sometimes reactive electrodes can also be used for like electroplating and stuff, but normally for electrolysis we prefer inert electrodes. So next question, give one property other than the conduction of electricity that makes this substance suitable. Oh, you see, this is exactly what I was talking about. So inertness, so you can write inert. It has to be inert, or you can say that it has to be unreactive. So slash unreactive, right? It has to be unreactive. Okay, so state the products of the electrolysis of molten lithium chloride. Lithium is positive, chlorine is negative. So okay, this is easy. Now they have mentioned negative electrode is cathode and positive is anode. So chloride being negative, it will go to the positive electrode and it will become chlorine. So CHLORINE. And positive, it will be lithium at the cathode. So now you can see that there's a pattern in these questions, and what they are really focusing on, right? So there's a pattern that which you can crack, and they are they're asking same concept. They're checking on the same concept repeatedly by changing these compounds in their questions. Sometimes they use potassium bromide, or things like that. Like in the previous question, they were using potassium bromide, right? So this time then the lithium chloride, and again lithium chloride is being used again. So it's the same question. So in the previous question, in this one, they are using again lithium bromide, right? So here in this question, what are they using? This was a bit different electrolysis, entirely different, like aqueous electrolysis. And here you see potassium iodide, but they are judging the same concept, that whether do you know that what will be the product at the anode or cathode, and what will be the charge on anode and cathode. So uh, so this is the topic, this is the thing that you must practice, and make sure that you understand this 100%. So question number 7, this question is about zinc and compounds of zinc. And molten zinc chloride is electrolyzed, and the incomplete apparatus is shown. So complete the diagram by completing the circuit to show the wires and power pack and labeling the anode. Okay, so anode is this one, that's positively charged. So, and that's anode. And you just draw a battery here, connect this one with here, labeling this a positive terminal of the battery, and this terminal labeling it as a negative. And wait, let me connect it with the terminal directly. Yeah, this. And like this. Okay, so completing the circuit to show the wires and the power pack. Yeah, that's the power pack. So power pack, and these are the wires, right? Okay, so yeah. All right, and now name the products formed. So what is being electrolyzed? Molten, yeah, again, molten electrolysis, zinc chloride. Zinc being a metal will have a positive charge. Chloride is from group 7, which will eventually turn into chlorine gas. So it is negative. So positive electrode, it will be chlorine. So again, you see they are, analyzing the same concept. So chlorine, and negative electrode is a metal zinc. Okay, so I hope this is clear. We move on to the next question. This question is about, so all these questions, these are from core. The extended questions will be like at the end of this lesson. I think there are two. So question number 8, this question is about metals. A steel spoon can be electroplated with nickel, and the apparatus is shown. Choose a word from the list which describes the nickel rod. Choose a word from the, okay, nickel rod, pure nickel rod. Okay, it is connected to a positive terminal, so that is going to be the anode, right? So yep, that's the anode. And the next one, describe the observations made during this electroplating at the yeah, so observations, right? So nothing is being deposited here. So so now we need to see. Okay, so yeah, so it will get smaller in size, because we have studied that, when you are electroplating, so whatever is being electroplated, the material that you want to coat this spoon with, so anode must be made of that material. So let's say if you want to cover this spoon with silver, so your anode must be made of silver, so it must be pure silver rod. If you want to electroplate this spoon in gold, so anode must be must be a pure gold rod, right? So and about the electrolyte, so whatever material you are electroplating your object with, so the electrolyte, the solution must contain the ions of that. So it's, you are electroplating your spoon with nickel, so this electrolyte must contain nickel ions. So if you are trying to electroplate this spoon with silver, so your anode should be made of pure silver, and the solution, the electrolyte, it must also contain silver ions separately, right? And yeah, so now what will happen? Describe the observations made during this electroplating at the pure nickel rod. So we say that it will get smaller in in size, right? So and this question has yeah, it has 2 marks, right? So pure nickel rod, so pure nickel rod will pure nickel rod gets smaller. So pure nickel rod gets smaller. Okay, spoon. For spoon, yeah. So since the nickel is being deposited on the spoon, so nickel is used to, give shine or to make the appearance, better, right? So the spoon will get shinier, right? So it will get shinier, and you can also say shiny, shinier. You can also say it will get silvery. So like they will accept these correct synonyms, right? So I think this is clear, and we move on to state one reason for electroplating an object. Yeah, so again, we have answered this question before. So to make objects more attractive, right? To make to make object to make the object more attractive, or more resistant to corrosion, right? More attractive. Okay, now question number 9, and this question is about electricity and chemical reactions. The electrolysis of concentrated aqueous potassium bromide using graphite electrodes forms hydrogen at the cathode and bromine at the anode. So the electrolyte becomes aqueous potassium hydroxide. Okay, so this is now aqueous electrolysis with the involvement of water. So state what is meant by the term electrolysis. Okay, so they are only figuring out whether you understand the definition, right? So you have this question has 2 marks. So you can say that that electrolysis means the breakdown by the passage of electricity, by the passage of electricity of an of an ionic compound in molten or aqueous state. Okay, so state why graphite is suitable for use an electrode, because it is inert, or it conducts electricity. So you must mention both of these points. So graphite is inert. Graphite is inert because not all substances that are only inert can be used. It must be able to conduct electricity at the same time. So it is inert, and graphite conducts electricity. So both should be there. Graphite conducts electricity. Okay, so next one, write an ionic half equation for the formation of hydrogen at the cathode, extended only. Okay, so hydrogen, so remember what I told you in my previous lesson about half equations is that what is a half equation? You will have a substance, a species in its ionic state on the left, and you will have the form of the same species in a neutral state, right? So hydrogen in the neutral state, it exists in the form of H2, and in its ionic state, it exists as H positive, right? So essence, and I've also explained that when the species contains a positive charge, so it must gain electrons, which will appear on the left. So it is gaining 2 electrons. So to balance this, we have 2 electrons, 2 atoms on the right. So we must start with 2H plus and then 2E minus. So this is your equation. So you can write 2H plus, and also write the state symbols AQ plus 2E minus. Each of these 2 hydrogens will gain 1 electron each, and it will change into H2. That's a gas, right? Okay, so Now, name the type of particle responsible for the transfer of charge in the conducting wires. So this is very important that you should focus on this, because sometimes students write ions here, which will be incorrect, because ions conduct electricity in the solution, not in the wires. So in the wires, the electrons pass through the wires and conduct electricity, not ions, right? Ions remain in the solution, will remain in the electrolyte. Electrons. Okay, so now name the type of particle responsible for the transfer of charge in aqueous potassium bromide. You see, now they are referring to the solution, the electrolyte itself. So it's the ions that conduct electricity, because ionic compounds in a solid state, they cannot conduct electricity, so they must be present in aqueous or molten state. So now the next part number 6, state the names of the products formed when electricity is passed through dilute aqueous potassium bromide. Name of the products formed when electricity is passed through dilute aqueous. Okay, so it's a dilute aqueous bromide. So you will have potassium ions and hydrogen from water, and you will have bromide from the sodium potassium bromide, and you will have OH from water, a negative ion, and uh, yeah, hold on. Okay, so OH negative. So now you can see that hydrogen is more less reactive than potassium, right? So at the anode, at the cathode, it is going to be hydrogen, because cathode is negatively charged. So hydrogen. And at the anode, so since it is a dilute aqueous potassium bromide, so for a halide to be deposited, the solution must be concentrated, right? So if it is dilute, then your OH will change into oxygen. So the answer is oxygen. So I hope this is clear. And yeah, now this question number, the last one, this is the last question. Yep. And but an extensive one. Okay, no problem. All right. So this question is about chemical reactions and electricity, the diagram, blah, blah, blah. Draw an arrow on the diagram to show the direction of electron flow. So remember that the electrons, okay, this is a bit more difficult. You see, they are not, they have not mentioned any charges on these, or they have not mentioned that which one is the electrode and which one is the cathode. So how will you figure it out, right? So, and both the electrodes, they are made of metals. Okay, so that is a super difficult question, right? So since zinc is lower in reactivity, let me just quickly take a look at the reactivity series. So I think that reactivity, like zinc, is it reactive? Then it is reactive than iron, right? So zinc will be losing electrons, and it will have it will have a positive charge, right? And iron will gain these electrons. So iron will have a negative charge. So how will you determine? Oh, they have written here. So zinc electrode dissolves in the electrolyte, forming Zn2 plus ions, right? So, and okay, all right. Okay, so then there's no need to go in that discussion. Okay, so now, yeah, this one becomes the anode, and this one becomes the cathode, right? Okay, so now this is going to be, yeah, this is a different type of electrolysis. I mean, this is not electrolysis. This is a cell, like galvanic cell. Anyways, so but we know that what is that, which one is anode and which one is cathode here. So but we have already discussed in our previous lesson that the electricity, the electrons will yeah, the direction of electron flow, right? Electron flow will be from positive to negative, from anode to cathode. So draw an arrow. Okay, so I think this will help. So write the ionic half equation for the reaction that occurs when the zinc electrode dissolves. Okay, so write the ionic half equation. So when the zinc dissolves, so zinc, it is, so they are already mentioning it, that it is changing into zinc 2, right? So zinc will is changing into 2 plus. And how is it changing into 2 plus? By losing 2 electrons. So that's it. So this will be the half equation. I hope this is clear. Yeah, that was rather simple. Next part, the reading on the voltmeter can be increased if either zinc or iron is replaced by another metal. Name a metal that can replace zinc and increase the reading on the voltmeter. So any metal above the zinc in the reactivity series will increase the reading on the voltmeter, right? So you can say that any metal above zinc in the reactivity series. So you can directly write any, you can pick a metal and you can write it, or you can only, it says name a metal, right? So zinc, so you can say aluminum or magnesium. So I think I should, let us write aluminum, because it is above zinc in the reactivity series. And name a metal that can replace iron and increase the reading on the voltmeter. So any metal less than in the reactivity, below, like less in reactivity than iron. So below iron, we have copper, mercury, silver, gold. So let us write silver. Yeah. Okay, so fuel cells are used to generate electricity. Name the reactants in a fuel cell. So in a fuel cell, we use hydrogen and oxygen. So name the reactants. Yeah, so hydrogen and oxygen. And name the waste product of a fuel cell. It's water. Okay. So electricity can be used to break down aqueous or molten ionic compounds. Name the process which uses electricity to break down aqueous or molten ionic compound. It is called electrolysis. That is the literal definition of electrolysis. Uh, electrolysis. So remember that you will be able to understand these questions better if you have watched the two videos before this one, two video lectures before this one. Electrolysis 4.1 part 1 and 4.1 electrolysis extended part 2. I've explained all these things in great detail in those videos. So if you're not understanding this, go watch those videos, then come back. And if you need one-on-one tutoring lessons, fill the Google form given in the description and I will contact you. Explain why the ionic compound needs to be aqueous or molten. Yeah, so that it can conduct electricity. So it will have the electrons must be mobile. So we write mobile ions. Ions must be mobile to conduct electricity. So mobile ions to conduct electricity. Okay, so last two questions. Brine is concentrated aqueous sodium chloride. Okay, name three substances which are manufactured by passing electricity through brine. Okay, so that is a tricky question. The brine is concentrated. See, it is aqueous electrolysis because we have it the word concentrated, which means that water is involved as well. So if you have, so we will have Na plus as a positive ion, hydrogen as a positive ion, Cl minus as a negative ion, and OH minus as a negative ion. Okay, so since hydrogen is less reactive than sodium, so sodium will not be deposited hydrogen, so you will get hydrogen gas. So so hydrogen, and since it is concentrated aqueous, so you will get chlorine, a halide, And 3, if it's okay, the third one will be sodium hydroxide. Yep. So these two remain in the solution. So whatever is left in the container, you just evaporate water out of it and you will get sodium hydroxide, right? So sodium hydroxide. Okay, so name a different substance formed when molten sodium chloride is used instead of a concentrated aqueous sodium chloride. So yeah, then since we don't have H plus now from water, so it will be sodium. Okay, so yeah, pretty tricky question this was. Okay, so this is how you will be answering questions about electrolysis. I think I've covered almost all the types of questions which can come up right on the exam. So I think we can conclude the lesson here. This will be all today from my side, and don't forget to join my community on school.com, skool.com. The name is High School Chemistry. The link is given in the description. And I offer free lessons on school.com once a month, and you can subscribe to a premium package where you will be able to attend lessons once a week, 4 lessons per month, plus the free one, 5 lessons per month. And this will be all for today. I'll see you in the next one. Take care. Goodbye.